Alright, so the next reactions of the carbonyl we are going to look at is reactions with ammonia derivative. Now the first question is, what is ammonia? Ammonia is NH3. Now when one of these hydrogen of ammonia is substituted with something, it becomes a derivative. So you might have something like H2N and then you have Z. Z means something there has been what? Substituted. Is that okay? So it depends on the substituent we have at that Z position, which can be another ammonia. The Z can be OH. The Z can also be another NH2, and so on and so forth. Alright? Now, in a situation where the Z is OH, you call it hydroxylamine. Is that okay? So hydroxylamine has that NH2 OH functional group or group. So if you have, let's say, a ketone or an aldehyde like CH3, okay, before we talk about that, CH3, and then you have CH double bond O plus, I told you that hydroxylamine is NH2OH. Now, what do you think will be the product of this reaction? Now, the general mechanism for the class of reaction like this is that if you have something like this, double bond O plus H2N and then Z, this will give us, what is going to happen is that this H2 will combine with oxygen to form water. So at the end of the day, water molecule will be eliminated. So we'll have this combining with this to form what? Water, which should be eliminated. So it means NZ will bind with this carbon and double bond. So that at the end of the day, my dear students, this is what you are going to get. Something like this, and then you have NZ. So the product for this particular one, I can write hydroxylamine like this, but if you want to write it the normal way for this mechanism now, you have to write it as H2N and then OH. It's still the same thing. So based on what we have just done, we say the general mechanism is a situation where this one will combine with water, with OH2O, and then water will be given off. And then when water is given off, what do you think will be the product of this reaction? It's going to give us CH3, CH, double bond. Here will be N, alright, and then here will be what? OH, plus the water that was given off. Now, this compound that is formed is called an enzyme. It's called what? An enzyme. That's why we said whenever aldehyde or ketone reacts with hydroxylamine, the product that it will form is an enzyme. This is the enzyme here. When nitrogen doubly bonded to what? OH, you call it an enzyme. So what kind of enzyme is this? This is 1,2-acetaldehyde enzyme, because it was actually acetaldehyde that formed that compound. This is acetaldehyde, so you call it the acetaldehyde, alright, enzyme. That is for the first case. Then for the second case is hydrazine. What is hydrazine? If you have something like this is a ketone. The first one we did was aldehyde. This is a ketone. Now, there was no way this thing could have actually been like this. I think maybe they made a mistake with the drawing. There was no way it could have just been like that. You're supposed to have C and at least double bond oxygen plus hydrazine. So wherever you have NH2, NH2 is hydrazine. Like I told you, you can have NH2 and then Z. When Z is OH, it's hydroxylamine. When Z is another NH2, it's hydrazine. So hydrazine reacts with this. Now the same mechanism will occur. What did we say was the normal way to write this? I can decide to write this as H2N. based on our understanding that this O will always combine with this H2 to give out what? Water. So it means one of our product here will be water, which is H2O. And then you are going to have CH3. Here will be 2 C. Here will be double bond N. And then you have are you sure? Yeah. There will be double bond N, and then you have N, and then you have another NH2. This is hydrazone. So when it reacts, when aldehyde or carbonyl compound, it can be aldehyde, it can be ketone, reacts with hydrazine, the product is hydrazone. If it reacts with hydroxylamine, it's going to give us ozyme. If it reacts with hydrazine, it's going to give us hydrazone. So you should take cognizance of all this. Very, very important. Now, let's look at some of the tests for aldehydes and ketone. How do you test for aldehyde and ketone? The first test we are going to look at is the Tolley's reagent. Now, Tolley's reagent is an ammoniacal solution of silver oxide. It's something that you just memorize. It is obtained by adding ammonia to a precipitated silver oxide present in a solution of silver nitrate and silver hydroxide. Now, what happens when this aldehyde or ketones are passed through the Tolley's reagent? So if they say give some of the tests for aldehyde and ketone, you say reaction with Tolley's reagent, which is silver ammoniacal, this silver, and then you have OH. Now what happens is, at the end of the day, this one is going to form the salts of the carboxylic acid, the ammonium salt of the carboxylic acid, plus 2Ag plus H2O plus 3NH3. Now, it can only react with aldehyde and not ketone. Alright, this can only form precipitate of silver with aldehyde and not ketone. Is that okay? This is also called the silver mirror test. You are going to see that interface there that contains the silver. It's called the silver mirror test. So if you are asked which test can be used to test for the identity of aldehyde and not ketone, but not ketone, you can say the silver mirror test. Alright, it's going to form an interface containing silver. The next one is the Ferlin solution. Ferlin solution is an alkaline solution of cupric complex with sodium potassium tantarate ion. Alright, now citrate ion, not tantarate. Tartarate ion, that's what I can actually see there. Tartarate ion. Now, one thing that you should know is that aldehyde is oxidized by this reagent. However, ketones are not oxidized by this reagent. Is that okay? Aldehydes are oxidized, but ketones is not oxidized by this reagent. So if you have something like this, arrow C double bond O, so you mean this one can also be used to test for the presence of aldehyde and not ketone. Cupric oxide plus hydroxide rather, plus then sodium hydroxide. This will also give us the carboxylic sodium salt of the carboxylic acid plus the cuprous ion plus what? H3O. Now you should also know that what actually happens here is that this one initially will be blue in color. Alright, and this one is the cupric ion, is the oxidized form. Cupric ion is actually the oxidized form. Why this one is the cuprous ion is actually the reduced form of it. Alright, this is the oxidized form, this is the reduced form. So it means it's an oxidation reduction reaction. Do you understand it? Where aldehyde are oxidized to the corresponding carboxylic acid, but it will actually come out as the source of the carboxylic acid because of the presence of sodium hydroxide. Do you understand? So that is one of the way to test for this. But ketones will not also undergo this reaction. Do you know why ketones will not undergo? Because ketones are not oxidized. Are you getting it? We say ketones cannot be oxidized to carboxylic acid. Now, Benedict solution also is the same way. It's an alkaline solution of cupric ion complex with citrate ion. It reacts the same way as the Ferlin. Are you getting it? But ketones do not react with Ferlins. They do not react with Benedict or Toluene's reagent. But aldehyde do react with all this. That is the reason why the aldehydes, the monosaccharide, can be distinguished using this particular test. Most of you did Benedict's test, Toluene's test, and Ferlin's test in your 200 level first semester biochemistry practical. Alright? Now, ketones can be oxidized by alkaline KMNO4 or hot concentrated HNO3 to form 2 carboxylic acid with fewer carbon than the original ketone. Alright? It's very, very possible. It can be oxidized by alkaline KMNO4 or hot concentrated HNO3 to form, but not by any of these reagents, Ferlin, Benedict, or Toluene's reagent. Is that okay? That's what you should know. Now, haloform reaction. Now, when we talk about haloform, under haloform, my dear students, that's where you have iodoform. Iodoform is CHI3. That is where you have chloroform. How many of you have heard of chloroform? That is that gives the significant hospital smell, which is CHCl3. This is chloroform. Is that okay? The iodoform test can also be used to distinguish aldehyde and ketone. Iodoform reaction. Now, ethanol and propanol react with iodine to confirm the presence of this carbonyl group. It is used to confirm the presence of this carbonyl group, especially the CH3CO group. Alright? It's called the iodoform test. Iodoform test. What you're actually confirming in iodoform test is this group here. You know, aldehyde have this group, ketone also have this group. True or false? Is when aldehyde now is now H. Why ketone can be another CH3 here. So it means aldehyde and ketones will give positive test to what? Haloform reaction. Are you getting it? So we have the one that we are going to look at is iodoform reaction. It means we are using this one. This one is chloroform. Why this is the iodoform? So if we have a compound like this, ROCO, we want to confirm the presence of this group here. What do? We react it with 3 molecules of iodine and 4 molecules of sodium hydroxide. Then you heat. This is going to form something like this. Alright? Plus iodoform, which is I3 plus what? 3H2O. Is that okay? Plus iodoform plus, alright, sodium, whatever. This, what you have here is called the iodoform. Alright, plus sodium chloride and so on, sodium iodide. Is that okay? So that will be the iodoform test. So the iodoform test, you may be asked, if it's an objective question, what does the iodoform test actually look to determine? What do we use the iodoform test to determine? To determine the presence of methyl ketones, or methyl ketone group. Then we have reactions with phosphorus. Reaction with phosphorus pentachloride. Both aldehyde and ketone react with phosphorus pentachloride to form gem dihalide. It's possible. We also talked about the reactions of gem dihalide with water or with OH, sodium hydroxide, to actually give the aldehydes and ketone. go back to the previous lecture. So both aldehyde and ketone react with PCl5 to form the jet dihalide. How? This is an aldehyde, for instance, reacting with PCl5. Now what will happen is, at the end of the day, this is what you are going to get. A gem dihalide, like I told you, is when you have two halogen on one carbon. So it will now be remaining 3. You know, out of here we had 5 before. Then at the end of the day, you are now having 3 chlorine. This oxygen that left here will come here. And then the 2 chloride will be, one will be here, one will be here, which is what we just have here. Is that okay? So that is that. Then we have the Schiff test. Dilute solution of aldehyde when added to Schiff's reagent. The Schiff's reagent, which is rosalinene hydrochloride dissolved in water, and its red color decolorized. By passing sulfur oxide, restore its red color. So when you pass, when aldehyde are added to Schiff reagent, the color initially would be, this color of the Schiff reagent initially is red. When aldehyde are added, it will become colorless, so it will decolorize it. All right. But when you add sulfur oxide, what it will do is that it will restore the color back. This test is only for aldehyde, and ketones do not actually show this test also, which is the Schiff test. Is that okay? So that is that for this particular one. I think the next lecture will be on carboxylic acid. We'll see in the next one.